All right, moving on, we've got the May 2011 Paper 2, Problem 2, Part B. So we're going to be using some of the same information that we had before, maybe a little bit different, and changing up to doing some, looking at some statistics problems here. So some of the customers at each cafe were given survey forms to complete to find out if they were satisfied with the standard of service they received. So we're asked in the first A, B, and C, parts A, B, and C, some basic probability questions. So the first says, what's the probability that the form shows dissatisfied? So we look at the total. So we know the denominator of our probability is going to be 120. And leave your answer as a fraction. And remember that for IB, you do not need to reduce. So once you have found the numerator for this problem, move on to the next part. So the probability that the form shows dissatisfied is 120 in the denominator. And how many were dissatisfied? Well, we look and they show us that there are a total of 40 dissatisfied customers out of the 120 customers. Move on. Do not reduce that fraction. Do not change it into a decimal. You're just creating for yourself one more place to make a mistake. In Part B, we're asked to find the probability that we are satisfied. So that would be, let's see, satisfied, and was completed at Sarah's snack bar. So how many forms were satisfied that were completed at Sarah's snack bar? That would be 34 out of 120 total customers. Now, the next part says, find the probability that the form shows dissatisfied given that it was completed at Alan's Diner. Remember, when we've got a given statement, we're reducing the amount of information in the denominator. So right here, we can see that the total number of people that completed the form at Alan's Diner is 28. Let me make a little arrow here for Part C. The total number that completed the form is 28, and how many of those were dissatisfied? 8. So 8 out of 28 were dissatisfied. Don't reduce the fraction. Don't change it into a percentage. Don't change it into a decimal. Just move on. All right, now we got another part of the question. So we're going to switch to some information that we're going to need to use to answer some questions about the chi-squared test of independence. A chi-squared test at the 5% significance level was carried out to determine whether there was any difference in the level of customer satisfaction in each of the cafes. So the first thing that we're going to be asked to do is to write down the null hypothesis. And we know that the null hypothesis, which we indicate with an H sub 0, says that what we're going to state is that customer satisfaction and what are the criteria that we're looking at? We're looking at whether they're satisfied depending on which cafe they ate at. So we're going to say customer satisfaction, and we could call that dining choice, but since they use the word cafe in the problem, I'm just going to say cafe choice. Customer satisfaction and cafe choice. Now remember, the null hypothesis is that we say that they are independent. Those two factors are independent. And that's what we're looking for in Part D. That's the null hypothesis. For Part E, we're asked to write down the number of degrees of freedom. So you don't have to show any work for this problem, but let's remember how we calculate the degrees of freedom. We calculate the number of rows. So I've got 1, 2, 3 rows, and oh no, I don't. Mary Kay, I messed up. I've got 2 rows, and I've got 3 columns. So 1, 2, 3 columns. So I use those numbers, and I say the number of rows minus 1. So that was 2 minus 1 times the number of columns minus 1. We had 3 minus 1. That gives me 1 times 2 is equal to 2. But since the problem says write down, you don't have to show all that work for part E. Now, in F, using your GDC, your graphic display calculator, find the calculated chi-squared value. Let's remember how to do this. In your calculator, you want to use the matrix function. So you will go to, let's see, second and hit the fourth button down on the left. That's matrix. And you're going to be setting up a new matrix. So go over to edit and hit enter. And we want to tell the calculator, remember the calculator is doing row by column. So we had 2 rows and 3 columns. So you'll change the dimensions or the size of your matrix to a 2 by 3 calculator. Now, enter the values into the matrix from this chart that you see. So you're just going to enter the 16, 8, 16, 26, 20, 34, 42, 28, and 50 into the matrix. Once you get that finished, then in your calculator, you're going to go to, and I'll write this down, we're going to go stat, and we're going to go over to tests. So we'll use stat tests, and then you want to scroll, you can scroll up, it might be faster, or down to option C, which is the chi-squared test. And after you do that, you're going to see that it says observe values A. And what you're going to do is just hit enter. That tells the calculator, yes, I put my observed values in A. Next, your cursor will go down to where it says expected values B. And what it's asking you is, do you want me to put the expected values in B? Just hit enter again, which says yes, and then hit enter a third time for calculate. And you'll see that the chi-squared value that your calculator comes up with is 0.754. That's all you have to write down. You're just writing down that, I'm on the wrong page. You're writing down that 0.754. So that's part F, 0.754. Now we have to write a conclusion for part G. You need to go look at the table, and if you did not do this when you were practicing this paper, I want you to go find the table right now and look under where it says 0.95, and then you're looking at 2 degrees of freedom, and the chi-squared, we're going to call that the critical value, is equal to 5.991. So you need to use that value when you're setting up the conclusion to your test. And then you need to write down something that shows that you understand that since, I need a little bit more space to write, since 0.754 is less than 5.991, and if you kind of think of what our test looked like, here was our critical value, that's our 5.991, and this was the area where we accept, and this is the area where we reject. If our chi-squared value that we calculated ended up over here, we reject the null hypothesis. Now, over on this side, since our 754 is less than 5.991, then that little graph you're not going to put into your description, then we say we do not reject or fail to reject the null hypothesis. So do not reject, which means we accept the null hypothesis, which really means that the two factors are independent.